This video is for Algebra 2, Section 8.7, and this is about applications of the exponential and log problems that we've been doing in Chapter 8. So basically, for this application, you've probably seen these equations before, but you just simply have to know the formula and then know what each letter represents, and then we'll use our calculator to do all the math. So in this equation below, notice it says P, so the P is right here. If you deposit P dollars, so P is your beginning amount. Okay. So if you deposit a certain amount of money into a bank account, and then you get an annual interest rate of R, so R, which you'll notice is right here, is your interest rate. And remember, percentages we always express as a decimal. And then it says compounded n times per year. So n is in two places. It's not only on the bottom of this fraction, but it's also up here in the exponent. And n represents how many times it's compounded per year. So it might say compounded monthly, right, which means n equals 12. Or it might say compounded quarterly, which means n equals 4. So you have to kind of interpret what n is based on how they describe how it's compounded. And then it says the amount A, so A is the amount you end up with. So A is the end amount. And then the last variable that they mention after T years. So T is the number of years. Okay, we'll get to the other one in just a minute. So look down at number 1. How much do you have? So in other words, how much do you end up with? So they're saying find A. Okay, how much would you have after 5 years? So T is 5. If you invested $5,000, so P is the amount you're going to invest, your beginning amount. So P is 5,000 at a rate of 5.5%. So remember, in order to change a percent to a decimal, you move your decimal 2 places to the left. So that would be the R is, that little thing there, sorry. The R is 0.055. And then it says compounded monthly, so that means that the n is 12. So we're going to set up that equation. A equals, because I'm trying to find A, in place of P, we're going to put 5,000. And I always want to see your setup, so don't go straight to your calculator. So 5,000. And then in parentheses, 1 plus R is 0.055. R over n is 12. And then the whole thing is raised to the nt, so that's going to be 12, and t is 5. So since everything on the right side is all numbers, I can just put that straight in my calculator in one step, and I suggest that you don't try to do it in multiple steps. We'll just put it all in one big step. So I'm going to say, looks, I wrote 500 over here when it was supposed to be 5,000. Sorry about that. Okay, so I'm going to put 5,000, parenthesis, 1 plus, so remember fractions, you do alpha, y equal, choose number 1. So I want 0.055 over 12. Make sure you move your cursor out of the fraction, close your parenthesis, and then the exponent is 12 times 5. So 12 times 5. Enter. And so they're saying that if you invest $5,000 with all these conditions, you're going to end up with $6,578. Now, since this number represents money, we're going to round it to 2 decimal places. So we're going to say and 52 cents. So 65.78.52. So 65.78.52, and that is money. Okay, so again, it's all about identifying what each variable represents and then plugging it into the equation. So skip down to number 3. Okay, number 3 says, find the amount you would have to invest. The amount you would have to invest. So they're saying find what? Find P, right? The beginning amount. So find P. Okay, what are they giving us? Find the amount you would have to invest at 8.5%. So R, move your decimal, is 0.085. Compounded quarterly, so N equals 4. In order to end up with $100,000. So the amount you end up with, the A, is 100,000. And then after 40 years, so T is 40. Okay, so we write our equation. A equals, so 100,000 equals, P we don't know, so just write down P. And then in parentheses, we have 1 plus, the rate is 0.085 over, let's see, the N was 4. And that's all raised to the NT. So that's going to be 4 times 40. So 4 times 40. Okay, so on this one, I've got the setup, and I always want to see the setup on these. But on this one, we're going to have to do a little bit in order to solve, because notice what I'm trying to solve for, the P is over there on the right side. So why don't we do this? Let's start by just putting all of this stuff in the calculator and see what number that equals. So in my calculator, I'm just going to do parentheses 1 plus fraction, so alpha y equals 0.085 over 4, and then move your cursor, close parentheses, and that's all being raised to 4 times 40. So all of that equals 163.4. So in place of that box, I'm going to put 163.4. So what I really have here is 100,000. Let me make this a little bit smaller, sorry. Whoops, sorry. Okay, so I have 100,000 equals P, and then remember in place of that parenthesis, we're going to put 163.4 times 163.4. So when you look at it that way, if you want to solve for P, wouldn't you just divide by the 163.4? So in my calculator, I'm going to do 100,000 divided by 163.4, and I get 611. And if I round it to the nearest, well, to the cents, 99 cents would go up to $612. So what this is saying is, if I start with $612, right, if I put it in the bank and I just leave it sit there for 40 years with these conditions, it's going to turn into $100,000. That's a lot. $612, right, for 40 years. So it's kind of like if you right now could muster up $612, go put it in the bank, assuming you get 8.5% interest that you're going to collect, which right now you probably won't get that. But over 40 years, it accrue up to $100,000. Okay, look at number 4. How long will it take? So what do we want to do? Find T. Okay, so find T. How long will it take to double your investment if you invest $6,000? So remember, I'm investing $6,000, so my beginning amount, the P, is $6,000. And they said I wanted to double my investment. So doesn't that mean I want to end up with $12,000? Okay. Let's see. That pays 8.25%. So R equals, if I move my decimal 2 spaces to the left, I'm going to have 0.0825. And then it says compounded monthly, so N equals 12. Okay, so we set up the equation. A is 12,000 equals P is 6,000. And then in parentheses, I have 1 plus, let's see, the R is 0.085 over n is 12. And this is all raised to the n times t, so that's going to be 12t. Okay, so this time, notice what I'm trying to solve for is up in the exponent. Notice what we've been trying to solve for changes. In the original problem, I was trying to solve for a, it was over here by itself. That's the easiest kind. On number 3, I was trying to solve for p, which was kind of buried in the right side. And now I'm trying to solve for t, which is in the exponent. So I know it's strange looking, but this is an exponential problem. And do you see that this part is the exponential part? Because this is the part that has a base and an exponent. So why don't we do a little simplifying? Let's start by getting rid of that 6,000, right? If I want to get rid of 6,000, couldn't I just divide by 6,000? And if I divide by 6,000, then over on the left side I have 12,000 divided by 6,000 is 2 equals, and since everything inside that parenthesis is numbers, let's simplify the parenthesis. What should go inside the parenthesis? Well, I've got 1 plus 0.0825 divided by 12. So that's 1.0068. And I know we normally only write 3 decimal places, but on something like this, you need to write a few more. So let's write 1.0068. 1.0068. And then that whole parenthesis is being raised to the 12t. Okay? So again, I know this looks ugly, but this is an exponential problem. And you remember in this chapter we said in order to solve an exponential, you have to change it to log form. So if I want to solve, I'm going to change this to log form. So I'm going to say log base. Well, isn't the base the 1.0068? Log base 1.0068 of the answer, so of 2, equals the exponent, which is 12t. Well, I can use my calculator and figure out what that log base 1 point whatever of 2 is. Remember how we do logs on the calculator? If you do alpha window and choose number 5, so I want my base to be 1.0068, log base that number of 2, so that gives me this 102 number. But look at my equation. If I want to solve for t, then don't I just want to divide by 12? So let's take that, what we got for that log, and divide by 12, and t is 8.523 years. So t is 8.523 years. So what that means is, if I invest $6,000 for 8.5 years, it'll turn into $12,000. Okay. So there's one other kind of equation. This one says if you deposit P dollars, so P is still the beginning amount, that hasn't changed, into a bank account paying an annual interest rate of R, that hasn't changed, R is still the percentage. But notice the difference on this one is it says compounded continuously. So that means compounding something means how often they add in interest. So if it's compounded monthly, that means every month they're going to add in the interest and start refiguring. Well, if it's compounded continuously, that means every day, every hour, every second, it's going to add in the interest and then refigure. So it basically, when it's compounded continuously, it's earning more for you. And then it says the amount A that you would have, so that's still the ending amount after t years. So the difference for this equation is that there is no n, because n is always how many times it's compounding. And on this one, it says it's compounding continuously. And that's why you'll notice right here, this equation has the E in it. It means it's exponential growth. Okay, so look at number 2. Number 2 says, how much would you have after 5 years? So we're trying to find A. So I'll say A equals, how much would you have after 5 years? So that's my T. If you invested $8,000, so that's the P. Interest rate is 6%, so R is 0.06. And then it says compounded continuously. So the fact that they said compounded continuously is what tells me I'm using this equation as opposed to the first one. Okay, so let's just start writing it out. A equals, P is 8,000, and then E to the R is 0.06, and that's R times T, so that's times 5. So again, since the A is already over there by itself, I can just put that entire right side into my calculator. I'm going to say 8,000 E. Remember, to get E, you can do that second ln. E to the 0.06 times 5. And I'll end up with $10,798.87. So $10,798.87. $10,798.87, and that is money. So start with 8,000. All I have to do is leave it for 5 years, and it'll turn into 10,700-ish. Okay, so look down at number, number 5. Find the time required. Okay, so we're trying to find time for an investment of 20,000. So that's my P. For an investment of 20,000 to reach 50,000. So that's the A. That's what I want to end up with. At an interest rate of 8%. So R is 0.08. And then the fact that they say compounded continuously is what tells me I'm going to use that second equation. So A equals PE to the RT. So A, 50,000, equals P, 20,000, E to the R is 0.08 times T, I don't know, so I'll put down my variable. Okay, so again, notice T's in the exponent. So the first thing I'm going to do is divide by 20,000. And if I do 50,000 divided by 20,000, let me show you something here. If I divide by 20,000, on the left side, you see that all of these zeros are just going to cancel out. You're just going to have 5 halves. So 5 halves equals, and all that's left on the right side is E to the 0.08 T. Okay, I've got the exponential by itself, so that means I need to change it to log form. But instead of saying log base E, what do we say if it's log base E? Don't we say natural log? So I'm going to say natural log of the answer, so of 5 halves, equals the exponent, which is 0.08 T. So if I want to solve for T, first I'll figure out what that natural log of 5 halves is, and then I'll divide by 0.08. So natural log 5 over 2, and that gives me this 0.916 number, and then I'm going to divide by 0.08. And so that means, and this is T, that means in 11.453 years, T equals 11.453 years. So in 11 and a half years, my 20,000 will turn into 50,000. All right, so when you're doing homework, remember it's important to go look for that compounded word, because if it says compounded continuously, you know you're going to use this second equation. But if it says compounded anything else, you know you're going to use the first equation. So again, you can always look back at these examples to see what you're trying to find to help you with the solving. So you just have the one page for homework.